So just as a reminder for everyone, the, the or just as a announcement or reminder based on whether you knew this or not, I've posted the USACO video from yesterday in the channel. So those of you that weren't here can go watch the past 2 days. I also posted the code in USACO, the bronze channel, so you could take a look at that. I am aware that the walking home problem may end up with the time limit exceeded. Unfortunately, I think it should work for the vast majority of them. It's like only one or two that don't work. So I guess the challenge for you would be to come up with a solution that does not require recursion, because recursion is a little bit wasteful. So you might want to try a solution that doesn't do it. So I'll leave it up to you to try it, because again, you have to, yeah, it's important for you to try coding it too, coming up with different ideas than what I'm doing. Because on the real, I'm sure on the real test, I won't be there to answer questions for you. All right, so any case, I'm going to begin on the problem. All right. Let me share. Oh, and do let me know anytime by speaking up, sending me a chat if you have any questions at all. I'd love to, so just interrupt me. You don't have to like raise your hand or something. Okay, so it says problem 2, daisy chains. Every day, as part of her walk around the farm, Bessie the cow visits her favorite pasture, which has N flowers. All colorful daisies labeled 1 to N lined up in a row, or 1 to 100. Flower I has P of I petals, and it could have up to 1,000 petals, which seems like a lot. So as a budding photographer, Bessie decides to take several photos of these flowers. So in particular, for every pair of flowers satisfying, one is less than I is less than J's, which is less than N. Bessie takes a photo of all flowers from flower I to flower J, so including them. So just remember the ranges are inclusive. But Bessie later looks at these photos and notices that some of these photos have an average flower, a flower that has P petals, where P is the exact average number of petals among all flowers in the photo. So how many of Bessie's photos have an average flower? Okay, so we have, okay, so it says the first line of input contains N, the second line contains N space separated integers, Pi to P of N, and you know Pi of P to N is the number of petals that a flower has. So the idea behind this problem is that you have a bunch of flowers in a row with petals on them. And then, so if you take a picture of any range of flowers, right? Let's see. Yeah, any range of like flowers, let's say 1 to 5, 5 to 10, 2 to 6, whatever. You're going to end up with the flower that has an average number of petals. What that means is that basically you're going to average the numbers, and you may end up with the whole number. And if you do see a whole number, you may see a flower with that particular number of flowers. Petals. It's like if you take a test and the teacher says the class average is, let's say, a 70%. So there may be one person in that class that got a 70%. So we would call that the average. Somebody got the average test score. It's kind of like that, except we have flowers and petal instead of test scores. So it says, let's see. So it looks like every picture in this example, every picture containing just a single flower contributes to the count. There are 4 of these in the example. So also the I of J ranges 1 of 2 and 2 to 4 in this example correspond to pictures that have an average flower. So what you have to do here is so basically what you have to do is you have to find ranges of numbers, right, that contain an average flower. So here, let's take a look at the whole thing. It might be a little bit easier to explain. So we have 1, 1, 2, 3, which I believe is, let's see. Wait, so every picture let me rephrase that. Every single picture containing just a single flower contributes to the count. And that makes sense because if you have just one flower in your array, that means by definition, that one flower is the average. It's like if you're in the room, the average intelligence of whoever's inside is your intelligence because there's only one person inside. It's a little bit deceptive, but that's how it is. So by definition, we have four already. Now, if you take a look at this, if you let's say that all of a sudden you decided to choose all four of these numbers. So we have 1, 1, 2, and 3. And if you add them up, you end up with 7, right? That's your total. And if you average them, you get 7 over 3, which I think is like 2 and 1/3. Obviously, there is no 2 and 1/3 here, so there is no average flower. There is no flower in the sample with 2 and 1/3 petals. That's just not how things are. If you think about it though, so let's say you decided to do 1, 1, and 2. 1, 1, and 2, if you sum them up, end up with, let's see, I'm trying to double check if this is correct. Sorry. Or if you have, let's say you did 1 and 1, right? You would see that the average here is pretty much 1, right? So that would correspond to one with an average flower. Here we have, here if you decide to look at 1, 2, and 3, you would see that the total is 6. And yeah, the total is 6. And the 6 divided by 3 is equal to 2, so you could see there is an average flower here. However, if you decided to 1, 1, and 2, the sum of that is 4. We have 3 elements, which makes it 4 divided by 3, which would obviously turn this into something that, yes, there's no flower with 4/3 petals. So unfortunately, there is no average flower in that sample. So you could see that the only real ranges with an average flower in it are just 1, 2, 3, 4 individual flowers. All count as one. These two over here, because 1 plus 1 equals 2. Average of 1 and 1 is just 1. There are ones here, and then you can see 1, 2, and 3 here. And then the average of 1, 2, and 3 is just 2. And then so you can see we have a 2 there. None of the other ranges satisfy our equation or satisfy our needs. Okay. So obviously at some point we have to run through all of the combinations of flowers, right? We have to all of the combinations of I and J. So at some point we're going to need 2 nested loops, one to control the starting location and one to control the ending location. However, there is a slight, yeah, basically. And I think the simplest way to go about this is just to sum everything up, divide it, and check if there is an average number within it. So I'm going to write the program it'll be a very simple program. And I guess one challenge that you could put yourself under is to basically try making a more efficient version of this program. Because I think I told you a while ago, don't waste your time doing repetitive things. Don't do the same thing over and over and over again. When you're doing this, you're adding the same numbers over and over and over again. So you may have learned about strategies like prefix sums in your class. Maybe you could apply that to make your program a little bit faster. So let's go ahead and program that. Oops, wrong button. All right. So you have to, okay, oops. So I'm going to start by, again, if you're a Java person, follow along, please. If you're a Python person, take my Java code and translate it into Python. It shouldn't be too hard. So first we do our imports. I sometimes forget that, so don't forget it. I'm going to do public class Daisy. That's the name of our problem. You could call it daisy change. I don't really mind what you call it. So we have, let's see, I'm going to make a main method public, oops, static void main. And if there are any errors in my code, just please let me know. I try not to make mistakes, but sometimes they happen. So scanner in equals new scanner, because that's how we read our input. So what I will do is I will make a loop int n that loops through things n number of times. So in dot text in, like that. And I'll make a for loop. I'll use a slightly unusual variable name because again, I'm going to be writing for loops inside of this outer for loop, and I want to be able to use a variable I in it potentially multiple times. So I don't want to use the variable I out here. So I'm just going to call it something strange like Q. Q is less than N, Q plus plus. I just name it something odd so I'm not tempted to reuse that name, or it's not something common that I would use. All right. And let's see. Oh, wait, never mind. This isn't one of those problems. This is a problem where you have, okay. Okay, I saw your message. So yeah, the person that sent me a message. Okay, yeah. Just make sure when you come back, you're caught up on this. So basically what we have to do is we have to this was a little bit misplaced. If this was one of those questions where we had multiple test cases in a single bunch, then this would have been inconvenient. But in this case, we only have one test case. It's a sequence of numbers. So it's not actually that, so it's not like we need for loops inside of for loops. So we could just leave it as I for now. Okay, that was my mistake. So I'm going to make int over here, int n equals new int. And I'm going to call that n. So n of I equals n dot next int. So we have that. And now what I'm going to do is I'm going to solve the question. So in this case, I'm just going to do something pretty standard. I'm going to, I'm going to write a for loop that contains I. That's our starting position. I'm going to write an an inner loop that contains, j equals 0, j is less than n, j plus plus. That'll be an inner loop, that'll be the ending position. So I'll annotate these. So this is the starting position. This is the ending position. Remember, this is inclusive. So whenever you move through this, you do want to make it you do want to remember to put less than or equal to. There we go. And then in this case, we do want to pay attention to fractions because you know what happens with fractions, right? There's no fractions inside of these integers, so we want to keep track of that. So we will make a double sum equals 0. You could do the same thing with integers where you have an integer sum, and you know what? Actually, I'll keep it as an integer for now. And sum equals 0. I will loop through the array and k equals I, which is our starting position. K is less than or equal to j. Remember the less than or equal to. J be equal to I. J should not be equal to I because we want these to be. Oh, actually, you are correct. That yes, actually, thank you for catching that. J should be equal to I. That's because that is absolutely correct. And the reason we need that is because we don't want to start J all the way at the beginning. Otherwise, I would actually be after J. And that's not what I could be after J, which would mean everything is in like reverse. And that would be kind of not good. So thank you for catching that. So K plus plus, we'll do sum plus equals n of K, like that. So we have our sum. So yeah. So basically what we want to do is so what we could do, obviously, we could make a double variable and we could divide it by the number of, number of things in there, blah, blah, blah. But I'm going with doubles. If you have not heard of it, have not heard, doubles are fairly slow. It's slower than int. They're pretty fast, but they're a little bit slower than int. So I try to avoid them whenever possible. Doubles are a little sometimes inexact. I mean, in this case, it doesn't matter. But as a rule of thumb, whenever I deal with these kinds of problems, I like to avoid using double. So there's a way to solve this without using double, and I'll guide you through it. I'll show you both versions actually. I'll show you the version with the double and the version without the double. Both should work. So I'll just make a double average equals sum divided by. Now we have to make sure you know how many elements are in this particular part of the array. It's j minus I, but that's not enough. Oh, the third for loop doesn't have curly braces because we only have one line after it. So for loops with only one line after it don't need curly braces. Yeah, so that's a good question. It's a bit of a shorthand. So if you want, you could put curly braces. I'm not saying that you can't. It's just that if you have a for loop with only one line that you want to run after it, you don't need them. So we have j minus I, which is the distance, and then plus one because j minus I would actually return the number of elements minus one. So we don't want that. So we want to add one to kind of correct for it because it's a little bit strange because j is inclusive. So that means we need to make everything less than or equal to, and we also need to add one just to reminder, just because it is inclusive. The interesting thing about this is that this is a double division. So if we just do what will happen here, if we don't modify it, is that this is an int, this is an int. So this will actually proceed as an integer division. And you know what happens in integer division, right? Like we toss away the decimal point. So we want to convert one of these operands into a double. So the easiest way to do it is just to turn this into a 1.0. And this whole thing becomes a double, then it's an int divided by a double. And if you remember, practice it, this whole thing will turn into a double. So integer divided by a double will proceed as if both operands were a double. So we'll get a decimal point. Another thing you could have done is turn sum into a double like that. There's many ways to do it. There's no right or wrong. Actually, I'm not going to say there's no wrong answer because a wrong answer would just be to leave both as ints. But there's more than one right answer to this. So if k equals I, and then we're just going to run through the whole thing again. Sorry, it should be k is less than or equal to j, and then k plus plus. Actually, and we'll make a variable. I'll keep things a little bit simpler. We will make a Boolean flag up here. And work contains. We'll say that in this for loop, if it contains, I will say it equals false. If n of k equals average, then contains equals true. And we don't need to search anymore because this is one of those questions where if you find one, you could just kind of abandon it. Like you don't have to run the for loop anymore because there's no point to it. I mean, like you already found it. So we hit break and we exit out of the loop. I mean, you could keep running it if you would like. I mean, it doesn't change the answer, it just makes things a little bit more efficient. So, and if contains equals true, we will make an int variable up here that says answer equals 0. We will do answer plus plus. And then we'll be out here and we'll system that out, print ln answer like that. So this is the solution with the double in it. Is int n of I is less than or is less than average or n of j? Is it sorted? Oh, is it sorted? I was not aware that it was sorted. I mean, yes, indeed, if it was sorted, I'm not sure where it says it's sorted in here. There was a question that wouldn't it be faster to check if n of I is less than or equal to average less than or equal to n of j because it's sorted? That's true. I'm not, that's, oh, what it's saying in, oh, it says what is less than or equal to I, less than or equal to j, less than or equal to n. That just says I must be less than or equal to j, and neither of them could be greater than 1 or less than or equal to n. So it doesn't say the petals have to be in any particular order. It just says that I has to be less than j. That's all. Less than or equal to j. So it's very easy to get confused. But yeah, it doesn't say P of I, which is those petals, has to be in order. It just says that these petals have to be it just says I has to be less than or equal to j. So yeah, and the sample input doesn't help because it's in order, so it's very easy to get that confused. But if it was sorted, you could actually use something called hopefully you learned this in class, a binary search to search through this really quickly instead of having to use a for loop. But unfortunately, the array is not sorted. It's just I is less than or equal to j. So they're referring to this I and this j, not necessarily n of k or n of I or n of j. So yeah, that was a good question though. So there is a way to do this without using the double, and I'll tell it to you. Yeah, I'll explain it right now. So when we have so you could see that when we summed everything up, right? We had we got a sum. And now you know that the deal breaker here is that if there is a fraction, we are completely 100% sure that there will not be any flower with that particular number of petals, because it's not like you could have like 2 and 2/3 petals. That just doesn't make sense. So what you can do is you could make sure before you try running it, you could make sure that if sum is modulo j minus I, plus 1 equals 0, if sum is a multiple of the number of elements that we've crossed over, so I'll just put length j minus I plus 1, so we'll put length. If it's a multiple, then we know that if we divide it, we're going to get a clean number. So I'll just say this is strategy 1. Or this is strategy with the double. And then this is strategy without the double. If they're both divisible, we know that the average is going to be a whole number. So we'll do sum divided by length. And we could basically run the same loop. And as Baron mentioned, if it was in order, you could definitely use something like a binary search to speed it up. Yeah, so I'll leave both of these here for you, but you have to choose between one of them. You don't want to have both run because it will double the value of the answer. So I'll keep it like that. So I'll uncomment this. I'll keep this one out because it's a little bit more straightforward. I'll comment this. So both should work. It's just this one is a little bit faster because, like I said, doubles are a little bit slower. This also filters out all of the answers that have decimals. So you actually run this fewer times because you don't have all of because you don't run the for loop when you know there's going to be decimals, and you don't run it when you know for sure that there's not going to be an answer. All right. Do you have any questions about this? Okay. So in that case, let me know if you have any additional questions as we go through this. I will be moving on to the next question in the interest of time. Actually, let me double check if this program works. Okay, it looks like it's reading from standard input. Let's see. I'm not logged in. So I will throw this program into USACO while we're working on the next program. Oh yeah, Oh, yeah, of course. Here is the full program. I'll put this on the Discord later on once we're done with class. So while you guys are writing it down, I will. All right. Anybody else need the code? All right. So I'm going to assume nobody else needs the code. Again, I will put this on the Discord, so it's not like, yeah. So if you're too shy to speak up, you can still see it afterwards. Oops. All right. So the next one is a little bit trickier. This one was this is a program called In a Rut or Stuck in a Rut. This one, I think I've done this one in my class a couple times, and then it's worked out, and we've been able to, yeah, solve it. So it looks like I've already solved this program. So yeah, you will see the little you'll see the little squares at the top. So Farmer John has recently expanded the size of his farms. So from the perspective of his cows, it is now effectively infinite in size. So whenever you see infinite in size or like this really large 2D grid of cells, think like you should immediately think, okay, I'm not going to make an array of booleans because if it's infinite size, then like I'm obviously not going to have enough memory to do it. What you have to think is I have to think about it in terms of like linear equations and lines and slopes and stuff like that. So it's very important that you do that because otherwise, if you just try to make an array of booleans, you're going to run out of memory, especially if it's really large. Because like if the grid is like 50 by 50, then it's fine. Like sure, make your two-dimensional array. But if you try making a two-dimensional array out of something that's like 10 to the ninth and 10 to the ninth, you're gonna run out of memory. So it says here that all coordinates are at most 100. So yes, you might end up with a 100 by 100 grid, which is, it's to 100 by 100 two-dimensional array isn't that bad, but it has no additional constraints, which means that it could go up to 10 to the 9. This means that you should probably be using a linear equation because linear equations, they work instantly no matter how far you are. Like you just find the slope and then you can find the intercept and you don't have to plot any points or like, draw stuff across two-dimensional arrays. Whenever you see large grids, especially look at the coordinates. If they're really large, then think about using linear equations. All right, so it says Farmer John has recently expanded the size of his farm. So blah, blah, blah. The cows think of the grazing area of the farm as an infinite grid of 2D square cells filled with delicious grass. Each of his and cows 1 through 50 starts out in a different cell. Some start facing north and some start facing east. So every hour, each cow either stops if the grass in the current cell was already eaten by another cow, and eats all of the grass in her current cell and moves one cell forward according to the direction she faces. So I have like for the sample input, I actually have a visualization. So it's a little bit easier to understand if you can see it. But basically the idea is that the cows are kind of like lawnmowers and they will eat the grass in one patch of the ground at the same rate. So it's not like one cow is like twice as fast as the other. They're all just think of them as all being lawnmowers, same model, same brand, same person operating or same kind of person operating it. So basically they will eat the grass until they hit a patch of grass that somebody else has already eaten and then they stop. So you need to determine how much grass was eaten by each cow. And some cows never stop, so they eat an infinite amount of grass. So imagine if you only have one cow in a field and the cow kept moving in one direction. Obviously, since this grid is infinite, it's never going to stop. So in this case, our sample, our first line of input contains n. Each of the next n lines describes the starting location of a cow in terms of a character that's either n or east, e. So pay very close attention to this. This is n or e. Don't be like me when I first started this program and say, you know what? I'm going to do north, south, east, and west because that's going to be a waste of your time because none of these are west or south. It's very important that you read these kinds of things so that you save some time. So two non-negative integers, which are of course the coordinates of the area of the cow, and all x coordinates and all y coordinates are distinct, so you won't ever have like a cow to the left of the other that is both moving east. What I mean by that is if you have a cow moving east like this, you won't have a cow right behind it. It won't hit the other cow like that. You won't see anything like that. Neither will you have a cow that's heading north, like heading up, and then you would have another cow right below it, and that will hit it. So that makes things a lot simpler. Because one thing that you can assume is that if the cows are running in the same direction, if they're both heading east, you could assume because they don't ever start on the same line, because you know if they started here, they would hit another cow. But since we can assume that they all start on different rows, you know, you could assume cows going in the same direction will never hit one another. So you could, yeah, so same thing for north, you could also assume that as well. So you can see these coordinates. It's very useful when you're doing these kinds of problems to visualize it. So that means either grabbing a piece of graph paper or notebook paper or whatever. But I decided to graph it. And I did this earlier in another class of mine. So we already have that. So it's already pre-prepared for you in the interest of time. I made this on Desmos, the graphing calculator. So you could see this is how the cows look like. So all of these different multicolored lines represent a different cow. So this cow, as you can see, starts at this 3,3 and it moves north. This cow moves to the east. And you have to know how far each cow could get before it hits a patch of grass that a cow has already eaten. In other words, you have to see how far it will go until it hits an intersection point. But that's not the entire story, because if you had read the question, you would have seen that each cow moves one grid at a time. So it's not like this. So it's not as simple as just saying, okay, you know what? I'm going to like, oh, look, there's an intersection here. So I'm just going to use systems of equations. It's not quite as simple as that because remember each cow. So like this cow, like the intersection here is not there. The cow doesn't move 2 units because like you can see there's a space of 2. But if you think about it, this red cow over here starts at 3,5. And this cow down here starts at 3,3. So this cow will continue moving on and on and on and on. And this cow will move up. But this cow has already eaten the grass at this square, right? So that means that it'll just stop here and it'll be the end of the story. But this cow gets to keep moving on and on and on and on. Because this cow takes time to get up here. They all move at the same speed. Now let's take a look at this. So you can see here, this cow has to move up, let's see, 1, 2, 3, 4. 4 units in order to reach this red line. This cow, however, has to move 5. So basically, you could see this cow is going to hit the rendezvous point a little bit faster than the red cow. So when this red cow is right here, this blue cow is going to be right at the intersection point, and it's going to have gone up and up. And it's going to have gone up here. The red cow would have moved here to this square. Uh-oh, this cow already ate all of the food here. So that means it's going to stop here. So hopefully that makes sense to everyone. If you have any questions about that, just please let me know or speak up. As you can see here, so basically, if you think about it, right? If you have to measure the length of this horizontal line, and you have to measure the length of this vertical line. So if this vertical line is shorter than this horizontal line, then this horizontal line will be the one that stops. If this vertical line is longer than the horizontal line, as is in this case, you could see this horizontal line is itty bitty, it's 1. Could see this one is slightly longer, it's 2. So this one will get to this point before this one does. So that means it'll go yum, yum, yum. It'll keep continuing this way. And this cow will continue on and it'll hit this square and it'll stop. So there's one wrinkle to this. Okay. Yeah, so there's one wrinkle to this, and I'll show you what that wrinkle is as we come up with the solution to this problem. So the most obvious way to deal with it is to take a specific cow, single them out. You go through each of the cows in turn, so it's not like this one is any special. You're just casting the spotlight on it for a couple minutes. So you take this cow, and then you compare it against all of these. And the minimum distance that it travels will be the answer for that particular cow. So you basically only look at 2 cows at a time. And then so what you do is that you look at this green cow and then you compare it against all the other 5, and then you look at the one below that, blah 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 blah. However, there is a little bit of a wrinkle. So if you take a look here, right? So you would assume that there is a cow moving in this direction, right? And then, so you would say, wait a second, the distance between here is 4 units. The distance here is, let's see, I don't even know, it's 4,6. Oh, it's 7 units. So therefore, this should continue going on in this direction forever. Or sorry, this one would have come across the rendezvous point, so this one would stop. However, that sounds good in theory, but what happens down here is that this red line, this black cow goes up here first, and it blocks this cow from going forward. So what really happens is that this cow should, in theory, block the purple cow, but what happens is that it gets stopped by the black cow and it stops. So that's why this purple cow gets to keep going yum 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 and keeps going across the screen without the red one blocking it because it got stopped. Yeah, so that is a wrinkle. That is a problem. So the way you would have figured this problem out, is if you had tried it. So if you would have tested these all out on your own, like using this very simple method that I told you, measure the lengths of these lines, see which one is shorter. By the way, if they are not shorter, if they're the same length, the cows keep going forward. So you do have to kind of account for that. The problem with that is that if you skip that one, you also have to account for all of the ones past it. So that gets a little bit tricky. So the solution to this is not only should we look at the lengths of these legs, right? We also want to take a look at how far the cow is actually going to travel, right? So in this case, this cow looks like it could travel as far as it needs here, right? It looks like it could travel all the way through here. And there's a little problem point here. So we want to know if this red cow will even get to that point in the first place, right? That's the big question here. So basically what you have, it's kind of like a recursive function. We call, for each one that we think can intersect it, we call it. We find out how long it's actually going to run. If it doesn't quite make it to the rendezvous point, so like if it gets stuck here, then we will assume that it's not a stopping point, and we will continue analyzing the line. Yeah, so it's just important that you see that little. It's a lot more logical if you draw it out on paper rather than think about it theoretically. So this is one case in which having a piece of paper out can help you significantly, or having a graphing calculator like this. All right. If anybody has any questions or would like me to clarify, just let me know. But since in the interest of time, I'm just going to get started with the programming. So this will be kind of like a strange version of a recursive algorithm, in that it will be a strange version of a recursive algorithm, is I think the best way to put it. So let's see. I'm going to open up that same window again. There we go. So the idea behind this is I'm going to make one method that will do all of the dirty work for us, which is calculating how far the cow will go. And basically, if we need to know, so we will be calling this method over and over again. Basically, inside of this method, we will be seeing how far the cow is actually supposed to go. And then we will be basing our, we will be doing calculations on it. So it'll be kind of pseudo recursive in a sense. So you'll see what I'm talking about. So I'm going to import java.util up here, set the syntax highlighting, public static, public class, oops, stuck in a rut. I'll just call this stuck. Then I will, since we're making a recursive function, we're going to have to keep some variables out in the open, like out as a field. We don't know which ones yet, and hopefully you kind of plan out your program before you do it, but I'm going to kind of explain to you while we write the program. So we'll write public static void main string args. I'll continue writing. So we will, we have, let's see, the very first number is int n, which is s.next int. Let's see. We will have arrays of, remember, direction. So we'll do char d equals new char, which is n, char, and we will have x's and y's. Oops, it should be int. Int x equals new int, and int y equals new int, and we will populate the array. So for int I equals 0, I is this put the n, I plus plus. We will do d of I is equal to in.next. And we'll just, in.next returns a string, so we can't use it directly, so just do char hat. X of I equals in.next. In x y dot I equals in.next. In. Like that. So what we have to do now is we have to print out a, we have to basically print out a, print out a value, basically. We have to print out values for each of these cows that are moving. So we're just going to make another for in I equals 0, I is less than n, I plus plus. We will make an, so here is a wrinkle that we're gonna like bring in. So basically we need to be able to refer to a number that's very large, right? And potentially very large numbers in addition to very what do you call it, very infinite numbers. Basically you would have to refer to infinity somehow. So that gets a little bit challenging because there is no way to store infinity inside of an int. There is a way to store infinity inside doubles, but we don't deal with that. We won't touch that for now. It's a little bit tricky how you could store infinity inside of doubles. So let's not bother with that for now. Instead, we will designate -1 as a, we'll designate -1 as a, what do you call it? As infinity. And that makes sense because you can't have cows eat a negative amount of grass. So we'll just say -1 is our code for infinity. So if our recursive method returns infinity, if it returns -1, we'll just print out infinity. So yeah, so this is our alternative to returning two values because Java can't return two values or ints can't store infinity. So what you have to do in these kinds of problems is to be clever. You have to figure out what range can my answers be in. And if there are numbers that are out of the range, like, infinity, -1, you might want to assign them special roles. Like -1 can be infinity, and that works because I won't ever have a number that's, I won't ever have a negative length. So it's okay if we treat it a little bit differently. So let's see. You could also use integer.max max value. I didn't do it, but in principle you could. There's no real difference between in this case in using -1 and integer.max value. So I will make a remember, the core of the problem I told you earlier was to write a method that does something very simple. It measures how far each cow goes. So we just pass it a cow number. It will compare it against every single other cow, and it'll return the shortest distance that it'll go before hitting another cow, if it hits a cow at all. So we'll call it static int check. We'll just pass it in a variable called I. In this case, our answer we'll just put, I know I haven't put any returns in there, so it'll be an error. But for now, I'll just put int answer equals check of I. If answer equals -1, we will do system.out.println infinity. Otherwise, we'll just do system.out.println answer. And again, you could do the same thing with the double. You could actually store infinity in doubles directly, but it gets a little bit tricky. So what we will do is we will actually I will I will revise it, because now that I'm thinking about it, -1 is not the best idea. We will just say integer.max value is our infinity. Because I was thinking about using math.min for this. I just realized if it's infinity, I just realized if I was trying to do math.min with -1, it will always return -1, which is not what I want, because -1 stands for infinity. So basically math.min would always return infinity, which doesn't really make sense. We'll just do integer.max value equals infinity. We'll just replace it with that. Oops. So yeah, I just thought of that. So we have int min equals integer max value. So it looks a little bit weird that we're setting the int min to integer.max value. It's because we're going to push min through math.min. So basically, we want this initial value to be extremely high so that math.min has something to work with. Whereas if we set it to 0, like 0 is already really small, so like math.min is not going to work very well. So for int j equals 0, j is less than or equal to n. This is the very first number that we have to take out, int n, because we can't see n from inside this method, so we need to take it out. We put static int n. I'm pretty sure we're going to have to use these variables too, so we'll take them out. We'll put static, and we'll just keep them as field. I'll take that out, and I will take that out. X and static int y. So it's okay to move your variables in and out of your functions, or sorry, your methods. Yeah, especially if you're like, oh, I want to turn this function recursive, then then you would have to take stuff out. So j plus plus. So basically, if we don't want to check the same, we don't want to check ourselves against ourselves, we will do if I equals j, then we will continue. We also don't want to check cows that are going in the same direction. So if d of I equals d of j, so if they're both going in the same direction, continue. This is if we're referring, it's like we're trying to figure out where we're going to intersect with ourselves. That doesn't make sense. Ourselves. Let's see. Don't check. Don't try parallel lines. We have. Let's see. We have. We have to find the distance between the x's and the y's. Distance d. So we'll do dx, distance between the x's. Or you could, if you want to sound fancy, you could say delta x. So math.abs. We need math.abs because some of them could be, some of them could be to the left. We don't want to end up with negative numbers. That's just nasty. oops, it should be x, x of j, oops, it should be y of j minus y of I. So the idea, so at this point, we know a couple of things, right? We know d of I is not equal to d of j. Or in other words, both of them, one is heading north and one is heading east. So it makes sense that if d of I is equal to n, so if we're the one moving north, then the other guy, j, has to be moving east because we already ruled out. Yeah, it must be true because we already ruled out what happened if they're equal. So let's do that. If d of I equals n, then the other d of j must be moving east. And that means that if we're moving north, then it's the y that matters. It's the y. So we will, if x of I is less than or equal to x of j, then we haven't moved horizontally fast enough. And otherwise, if we do, well, I realize I'm almost out of time, so I will try to speed things up. Y of j. There is no solution that we will miss. It's kind of like think of them as two trains, and then like there's no like there's no like stoppings or crossings. I was actually on a train a couple weeks ago, and they on real tracks they do stop for other trains that are heading the same way. But pretend this is like crazy world, and like they didn't care, they didn't stop, or they didn't care about stopping or starting or whenever the other trains were. Basically, in this case, the trains would just miss like a near miss. So in another case, let's say that two trains were heading in one direction, and it's a little bit morbid, but let's say two trains were on a collision course, but one of the trains got in an accident before it could hit the collision course. So the other one would just move across safely. A little bit more, it's a morbid example, but that's the that's the example. So if dx is less than dy, so if the distance doing the x's is less than the distance between the y, and if so this is the trick that we use. If if the actual length of this train is less than or equal to, it's greater than or equal to dx, right? So we only do this if we only want to do this if the train will actually reach us at, reach the rendezvous point, so it doesn't crash into another train beforehand. So we will update it. So this is a train. This is a possible stopping point. So we'll do min equals math dot min, and then dy. Because again, this is a distance between, yeah. Well, this train is moving up northward, so we need to find dy. I'm going to spare you the explanation for the bottom one because it's pretty much the same thing except the signs are just flipped. And that makes sense because if we're flipping it from the, if we're flipping the direction, it makes sense to flip the sign. Yeah, so I'm going to flip the signs, and I'm going to flip the signs over here, and then I'm gonna change some of the, I'm gonna change some of the values. So again, this is dx. We are interested in check dy here. We have to change these, but everything else looks pretty good. So we will return min here. A word of advice, sometimes people like to switch these two. I would advise that you don't. The thing about and it's a really obscure fact, is that and will only evaluate this if dx is less than dy. So if this is not true, and is like, why should I even evaluate this? And it will not. Usually it doesn't matter. In your case, you could just assume it evaluates both because there's no, like, in this case, like nothing, like there's no real, like, there's no problem if you evaluate both of them. Here, there is a little bit of an issue if we evaluate them because evaluating this side of the and requires us to call check again. So in this, it's a little bit strange to think of and having like, oh, it matters what side they come in on. But the real issue is that this one has to be true in order for this one to be executed. Kind of like if you have two if statements inside of each other, you need the outer one to be true in order for the inner one to work. That's kind of the same idea. So you want to save yourself time, put the check J over here. So we don't run check J by default. We only run it here when this is true. All right. So this is the end of our, yeah, this is the end of the code. You could take a look at the whole thing here. Yeah, I think this should fit the whole, yeah, this should fit the whole screen. You could copy it down. I'm going to give you this code later on the Discord so you could take a look at it. Tomorrow it will be, let me check who is teaching tomorrow. Mhm. I believe it is the excellent Solomon teacher. So Solomon teacher will be teaching tomorrow, so I won't be here. You might have to move to a different Zoom room because this is my personal Zoom room. Um, yeah, so there will be no hosts here, so there's no recording going on. So remember, if there may be a Zoom room link change next week. So just be, oh, sorry, not next week, tomorrow. Yeah. Yes, so it's going to be Solomon teacher tomorrow and Minyoung teacher on Friday. So be on the lookout for changed Zoom links because this is technically the one that I use for my classes and I use it so I could record class. But if I'm not here, they don't have my account, so they can't record my classes. So just be on the lookout, come to the right link if they announce it. So yeah, so I will not be here until next week. I'll resume, yeah, next week on the 14th. So you won't see me again for better or for worse for a whole week. So hopefully you guys learned a little bit through this. These problems were a little bit tricky, but yeah, they were a little bit tricky. I will say that. So good work. If you have any questions, please stay. If you don't have any other questions, have a nice evening and I will see you guys next week.